Imagine you could ask your city anything. How many foreigners live in Zurich? Where are the safest bike routes? Which district has the highest average income? Or even, does Zurich have a London-style banana of low crime rates and prosperity? Thanks to Freedom of Information Act passed in many countries, cities publish a lot of open government data. Traffic, trees, noise, playgrounds, you name it. These vast amounts of datasets make finding the right ones difficult and time-consuming. Let alone, if you want to analyze them further, it usually requires expert knowledge and tools. Therefore, I would argue that open government data is not really accessible to everyone. In my thesis, I try to tackle this gap. With my prototype OGD4All, I want to explore ways of making open data more accessible and enable everyone to get transparent, reproducible maps, plots, and text answers to their questions. OGD4All consists of two main stages. In dataset retrieval, the goal is to find the right datasets for answering your question, and subsequently, in the analysis stage, we actually process the data to generate answers. Let's look into dataset retrieval with a bit more detail first. The system applies two main tricks to find the right datasets more reliably. First, an LLM is responsible for reformulating the question into one or potentially multiple queries. Then, these queries get semantically embedded into a dense vector, using OpenAI's most powerful embedding model. Using semantic embeddings helps overcome the so-called vocabulary problem, meaning we can still find relevant datasets even if we don't have any of the exact keywords in our query. In this semantic vector space, we search for the nearest neighbors and then supply the dataset descriptions and other metadata to the same LLM. The LLM's job is then to judge which of the matches actually contain the relevant data and pass these on to the analysis stage. In my benchmark of 200 questions with the open data of Zurich, that reformulation plus semantic combo outperformed all other approaches and hits 94% recall, meaning it almost always manages to find the relevant datasets. In the analysis stage, an LLM-based coding agent iterates in a loop of planning its next step, generating associated code, executing it, and observing results. Once it is confident, it outputs its answer in text, accompanied potentially by interactive maps or plots. This iterative coding approach outperformed a less agentic version and reached approximately 98% correctness on the previously mentioned benchmark with 200 questions, given it is supplied the relevant datasets. This benchmark was tailored to cover many types of answers, domains, and required geospatial operations. Let's see the prototype in action. I'm testing it with 430 datasets of the City of Zurich, and I'm running a web interface through a simple radio server. I can ask it to fact-check tables I saw in a news article, and follow up with more questions. Or maybe I want to have it show me how the number of electric cars changed over the years. Or show me where the city plans to plant new trees. The system was tested across German, English, French, and Italian, with German working the best overall, likely as all the datasets and documentation about them is in German. Apart from these promising results, it is important to acknowledge several risks associated with the current approach. As with all LLM applications, hallucinations can occur, in our case potentially leading to incorrect outputs that might seem convincing at a first glance. Furthermore, OGD4All relies on OpenAI's frontier models, which were trained behind closed curtains, resulting in a risk of built-in biases or deliberate manipulations. Before wrapping up, let's return to our London banana. and see whether we can find something similar for Zurich. Looking at crime rates, tree density, income, and rent prices over different districts, no fruit shape seems to emerge, except maybe a banana for rent prices. Still, the point is, with OGD4All, whatever you can think of becomes a testable hypothesis using local, verified open data. If you want to learn more, feel free to check out the project through the link in the video description. Thanks.